IPC notes for IPC 7B. So at the top of your paper, in the margin up at the top, we put IPC I7B. These are the notes that we're going to be taking. So write these down exactly as I do. So I7B says that you're going to recognize that chemical changes can occur when substances react to form different substances. And I'm going to put the abbreviation DIF for different substances. So recognize that chemical changes can occur when substances react to form different substances, and that these interactions are largely determined by the valence electrons. Go ahead. I can't pause it, so go ahead.
I was going to talk to you about the labs for the next unit, so I can come back after school.
Okay, thank you. Okay, so I'm going to have some abbreviations in here because just like you, I get tired of writing the same things over and over again. So I'm going to point out some abbreviations to you as we go. Now I'm going to draw a line here because from this point down, we have the TEK. This is just telling us what we have to know. Now we're going to take the notes on this. So I'm going to change colors of ink. And the first thing you need to know is about chemical changes. Here's my first abbreviation. I'm going to get tired of writing chemical, so I'll write chemical or chem changes. Chemical changes, we look for evidence. What is their proof that a reaction has happened? And you usually look for more than one piece of proof, but here's a list of things that we look for. So one, we look for new substances created. Something new created. Like for example, if we take sodium, which is a shiny metal that if you stick it in water it explodes or bursts into fire, and then we take this poisonous greenish yellow gas called chlorine, and if we chemically react them together, we get a totally new substance that we can eat. Both the other two pieces are poisonous to us. So if we have sodium metal plus chlorine gas, we get sodium chloride, which we like on our fries here. So we look for a new substance that's been created. The second thing is we look to see if a gas is produced. And by that, what we do is we look for bubbles or an odor change. One of those two lets us know that a gas has been produced. The third one is we look for a temperature change. It may get colder, it may get hotter, and you know, our hands are not the best tools to use for this. We really need to use tools like a thermometer of some kind. We look for a precipitate formed. This is when you get two solutions, two liquids, and you put them together, and all of a sudden it turns cloudy, and if you let it sit for a while, this solid stuff sinks down to the bottom because it won't dissolve. So a precipitate is formed. It's a solid in a solution. Solution means you just dissolve something in water. The fifth thing you look for is a color change. And when I say color change, I don't mean, oh, well, I put blue food coloring in the water and it turned blue. This is an unexpected. Like when I put a blue substance together and a yellow substance together, all of a sudden I get orange. So we're looking for an unexpected color change here. And then the last thing we look for is some kind of light produced. That would be an example of a chemical reaction. Now again, we look for more than one of these. So for example, if I turn the light on, I know light's produced, but I know that's not a chemical reaction that's going on here. Or again, if I put the food coloring in water, if I put chocolate into milk, I know it's going to turn brown. That's not what that's an expected thing. So we look for more than one thing so we have absolute proof that we have a chemical reaction occurring. So here's an example of a chemical reaction, and this is one of the important examples of a chemical reaction because you'll have this all in the biology class too. So C6H12O6, and I know you guys looked at this last year, and I'm going to leave a blank space so we can balance this. Plus O2 produces, the arrow means it's a yield sign or produces sign, CO2 plus H2O. Okay, so we have these things, and I'm going to put in parentheses plus energy because this is the process where your body takes sugar, the food that you eat, and produces energy in the form of ATP, and that's something that's really important. We're studying that right now in biology. So when I balance this equation, I have to follow the law of conservation of mass, which says that I have to have the same number of atoms or molecules on both sides. I can't have, oh well look, there are 8 oxygen atoms on one side and only 3 on the other, because the law of conservation of matter says matter can neither be created nor destroyed. The law of conservation of mass says however many grams I start out with, that's how many grams I end up with. So I have to have a balanced equation. So this balances with these coefficients in front of these. So now what I'm going to do is I'm going to take these and let's label some of these parts. So this is called a yield sign. So when you read this, you have C6H12O6 plus 6O2 yields the other stuff over here. Or you can say instead of yields, you can also call it a produces. You can say it produces it. These things on this side are reactants. And this should be a reminder to you guys because I know you studied this in your 8th grade class too. These are the products on this side. The big numbers right here, like in the front of this, the big numbers are called coefficients. And the little numbers right here are called subscripts. When you only use the subscripts when you're trying to figure out what the formula for something is, and that's something you'll study in chemistry. And you only use the coefficients when you're trying to balance the reaction. Okay? So when I look at this, the other thing I can label on here is what all the chemicals are. So the chemicals in this thing right here, this is glucose, otherwise known as a simple form of sugar. Here's oxygen, you guys already know that one. This is carbon dioxide, I think you guys know that one too. And then this one, obviously you guys know this one, this is water. So we label a lot of things that are on here like this. Okay. What happens is that the properties of the reactants are going to be different than the properties of the product. So let's write that down. Properties of reactants are different from the properties of the products. And if you look at this, you know this is true. That's sugar. That's got certain characteristics. You know what sugar's like. It tastes sweet to the tongue when you put it on there. This over here, carbon dioxide and water, you know what water tastes like. Breathe out, and that's carbon dioxide. They aren't anything at all like the sugar on this side. Oxygen is not the same thing as carbon dioxide or water. Both of these, if you're just inhaling carbon dioxide, you're going to die. If you're just inhaling water, you're going to die. You need pure oxygen in this case. So the properties of these individual pieces are not the same as the properties over here. We have new substances created. Now it says that we also have to understand that these interactions are largely determined by the valence electrons. Valence electrons, okay. Valence electrons. Valence electrons, and I usually, when I'm teaching chemistry, I usually abbreviate electrons as a lowercase letter e with a negative sign. Those are electrons. You guys know electrons are negative here. So the valence electrons are the electrons in the outermost orbit. So when you draw the atom, the electrons in the outermost orbit are called the valence electrons. These are the electrons that determine the chemical properties of the atom, or the element if you want to call it that. So when you studied the periodic table, you studied all the group 1 elements, with the exception of hydrogen, are the alkali metals, and all the group 2 are the alkali earth metals. And if they're in the same group, they have similar properties. And when I say chemical properties, how it will react with other elements, that's what I'm talking about. How it will react with other stuff, elements. Okay? And with valence electrons, the magic number is 8. Don't know why. Oh, I forgot an is in there, so let me fix that. The magic number is 8. That means when they have 8 valence electrons, they're stable. So when most atoms have 8 valence electrons, they're stable. They quit reacting. So atoms are usually more stable when they are in a chemical bond with something. They get 8 by sharing or transferring electrons, which you already talked about, ionic bonding and covalent bonding. So we're sharing or transferring the valence electrons. Now, remember, I'm going to put a little note down here. This is called bonding. That's when you say you transfer or share electrons, it's called bonding. So when we have bonding, there are 2 most important types. We'll ignore the metallic bonding. We have covalent. They share electrons. And we have ionic. They transfer electrons. Remember that covalent bonds are between non-metal and a non-metal, and ionic bonds are between a non-metal and a metal. Okay? So write these notes down, take a picture, load it, and this will be for a grade.